Here we will discuss question number 31 of GATE 2019 of Civil Engineering afternoon session. The question is, a singly reinforced rectangular concrete beam of width 300 mm and effective depth 400 mm is to be designed using M25 grade of concrete and Fe 500 grade of reinforcing steel. For the beam to be under reinforced, the maximum number of 16 mm diameter reinforcing bars that can be provided is. So here width of the beam is given, that is equals to 300 mm. Similarly, effective depth of the beam, that is small d, equals to 400 mm. Then grade of concrete, that is M25. Grade of steel, that is Fe 500. And diameter of steel bar, that is 16 mm. And number of bars is to be calculated. So here the question is somewhat difficult, since the student has to understand the question, what are the given parameters, and accordingly he has to solve it by remembering or by recalling a particular equation. When we are talking about under reinforced beam, so for under reinforced beam, AST limited can be given as 0.36 FCK XU limited multiplied by B divided by 0.87 Fy, where FCK, it is the characteristic strength of the concrete, then XU, it is the neutral axis depth, B is the width of the beam, and Fy is the characteristic strength of the steel. So if we just see for Fe 500, that is our case. So in case of Fe 500, XU max by D ratio, that is equals to 0.46. And accordingly, we already have D, that is effective depth, and we can calculate XU max, that is XU limited in our case. So by putting values of FCK, XU limited, B and Fy, then the equation will be like this: 0.36 multiplied by FCK is 25 grade of concrete multiplied by Fe 500, that is our, in case of Fe 500 we have XU max, that is equals to 0.46 multiplied by D, and this is equals to. So this is the trick here. You have to remember this part. You have to remember what is the value of what is the value of XU max by D in case of Fe 500. Then width of the beam is already given, that is 300 mm, 0.8, and that divided by 0.87 multiplied by grade of steel 500. So if we just calculate, we'll get it's around 1142.64 mm square. Then once we calculate AST, then we have to find out using 16 mm diameter reinforcing bars, we have to calculate number of bars, and that is equals to AST divided by a diameter of 1 bar. So number of bars can be denoted by N, that is equals to AST limited divided by pi by 4 into D square. Now here D is the diameter of the bar. So if we just put the value of AST limited, that is equals to 1142.64, and D, that is the diameter of bar, that is equals to 16 mm. So we will get finally diameter of number of bars equals to 5. So here question setter asks the question, what is the number of bars in case of under reinforced beam, and the known parameters were width of the beam, effective depth, grade of concrete, and grade of steel. So accordingly, for under-reinforced beam, you have to just recall the formula for AST limited. So this formula is important in our problem. So once you know this formula, then the second one is this particular value for Fe500, that is 0.46, and that increases once you decrease the grade of steel. 0.48 in case of 415 and 0.53 in case of 250. So after putting this value, we'll get AST, and afterwards once you got AST, number of bars equals to AST divided by area of 1 bar. So this is how this problem is to be solved.